Now, on to Jerry Sanders, who is from NASA, the ISRU System Capability Lead. Jerry, can you hear us?
Yes, can you hear me?
Yes, we can. Over to you, Jerry.
Okay, well, let's bring up the slides and I'll start advancing. Thank you all for allowing me to speak to you today. I too wish I was back in Luxembourg there live and look forward to future. I think I've worked with On Hill and others long enough that we seem to know what each other is going to do ahead of time. So interestingly enough, I am starting my presentation a little bit on the why as well. And, you know, and to give you a sense of where we're going with NASA and space resources, you need to start again as to the why. And you know, we started out, and I saw in the chat box, you know, these are things that we do. We love to explore. There's the prestige, the national pride. There's the scientific aspects. We've seen over the years that it's encouraged international cooperation and partnerships. There was mention of the long-term security and survival of our species, but to be clear, there are two really important aspects that have really grown over the last decade or so. One is to stimulate the economic development and expansion of our economies. The other is to make life better on Earth. Then the second kind of question that comes up is the how we explore has evolved over time. You're all familiar with the government-led and funded activities. You know, 60 years ago, almost to the day, Yuri Gagarin flew into space. 40 years ago, the space shuttle flew for the first time. And the space station itself that's in orbit has been government funded and led. But over time, we've seen a drastic change, and it's been slow, but it's kind of gaining momentum where commercial partners are starting to become more involved. We've heard discussions about what's happening in Earth orbit with respect to cargo and crew delivery, and now habitats are coming online that are commercially provided, and satellite servicing. This commercial partnership is going outside the Earth orbit. The CLPS, the Commercial Lunar Payload Services. Just recently, NASA announced the Human Lunar System commercial activities, and we can expect that propellants at some point will also become commercial. And then even outside of government partnerships or government-led activities, there's commercial-led activities dealing with orbital tourism and suborbital tourism and even beyond that. What's important to NASA and to reinvigorate and direct us to support the commercialization of space, we follow the space policy directives. The first one being that the U.S. lead the return of humans to the moon, but to do so with industry and our commercial partners. So then we go on to space resources, and we've called this several things over the years, living off the land. I like the prospect to product terminology because it kind of encompasses the whole mining cycle. In general, ISRU involves any hardware or operation that harnesses and utilizes in situ resources to create products and services for whether it's robotic or human exploration and commercialization of space. We start with resource prospecting or resource exploration, as it's more properly termed, and in particular looking for waters and minerals when we think of the moon. We are following two kind of branches at the moment, and I'll go into that more. There's the regolith and how you would process it for oxygen and metals, as has been mentioned. But there's the water and the volatiles that exist in the permanently shadowed craters. And with these products, we can move on to other activities such as manufacturing with derived feedstocks, whether they're the bulk regoliths itself or plastics and metals and ceramics, or surface construction that could be civil engineering or the construction of structures. And then obviously product storage and delivery for multiple users. Now, within NASA, Space Resource Development is primarily under the Space Technology Mission Directorate, and it has mission and guiding principles such that it looks at developing critical technologies that sustain lunar surface presence, help us get onto Mars, and enable science and commercial activities in the future. And it's accomplished through focusing on critical technologies and then keeping the space, what they call technology pipeline, growing and emerging with new innovative technologies. In general, STMD does this through ground development activities and even flight demonstrations. And when I talk about this, the technology pipeline, or I like to call it the worm chart, it basically allows us to look at the spectrum of very early ideas, our NASA innovative advanced contracts, or like the TRL 1 to 2, where you've drawn something on a napkin that could change the world, all the way to our technology development and flight demonstration program on the right. Most of the work that we are focusing on with respect to getting into demonstrations comes through our SBIR, or Small Business Innovation Research activities, our technical maturation or game-changing development, GCD, and then our partnerships. But we do rely on touching with our early stage innovation, which includes universities and students and such, as well as our advancements with industry, such as our tipping points. And interestingly enough, each one of these different areas has a different pot of money associated with it, and different solicitations. As I mentioned, the SBIR, I'm not sure if you can see my cursor or not, but at the top left column is a significant amount of money, as well as our tipping point, which is kind of at the bottom of the right-hand column, deals with how we interact with different companies and such. And those types of solicitations require that the companies involved either provide 10 to 20% or more of the funding to get the final technology or product completed. Now, that pipeline, as I mentioned, has a lot of different solicitations, a lot of different companies and universities and even internal to NASA. So how do we try to focus all those individual efforts? And one way is through my job, for example, where I coordinate all in situ resource utilization technology across the agency. Another is the Lunar Surface Innovation Initiative within the STMD. And Ben Bussey, after me, will talk a little bit more about this, where we've identified 6 particular areas we want to really invest in that we see as the long-term goals and technologies for sustainability, ISRU being one of them, surface excavation and construction being another. Also sustainable power. Obviously, we can't do anything on these planetary surfaces and in space without large amounts of power for these operations. How you deal with dust and the abrasive regolith. How do you get into extremely difficult locations or deal with extreme environments like the permanently shadowed craters? Those are all extremely important. And as part of the Lunar Surface Innovation Initiative, NASA is working with the Applied Physics Lab to create the Lunar Surface Innovation Consortium. And again, Ben will talk a lot more about that in particular. The LSIC is there to help work on how do we get industry and academia and commercial partnerships and even international partnerships involved in the space development activities. And in one case, for example, they held a half-day workshop called the Supply and Demand Workshop, where we had several companies talk about how they might provide propellants, several companies that deal with transportation systems on how they might actually utilize in situ propellants versus earth-derived. And this kind of workshop helps bring both sides of the table, the supply and demand, the market, and the producers, get a sense of where we need to go to enable both of these to go forward simultaneously. So within NASA and the ISRU program, we are focusing particularly on two pathways, as I mentioned, the water and the potential volatiles that are in the permanently shadowed craters. As has been noted, it provides tremendous chemical propellant capabilities. It strongly influences where and how you explore the moon, and it is game-changing overall. That said, oxygen from regolith and metals still provides significant benefit. If you look at chemical propulsion systems, 75 to 80% of the propellant mass is oxygen, so you still get a huge benefit. And the regolith itself contains over 40% by mass of oxygen in different minerals, so it's extremely beneficial. So the approach is to lead with water mining because of the uncertainties with the resource, but the game-changing aspect of it. But obviously to follow with oxygen from regolith, since it's potentially a lower risk, but maybe not as highly beneficial as the water. And so to do this, we're taking several factors into consideration in our development plan. First is to know the customer's needs and gaps. This is not just, again, governments, but industry and academia and international partners, working with our Artemis elements, the ISEC-G and commercial industry. Then performing ground development of the hardware and systems until we can get to flight, through selecting those critical technologies and components that could potentially get us to Mars as well. So understanding, is there a Mars forward aspect? And then making sure that what we're working on is what's needed. So again, engaging industry, academia, and the public. Before, obviously, we use ISRU in mission-critical roles, we have to demonstrate it. So we're using our commercial lunar payload services missions to better understand the resources that exist, obtain critical data about the regolith and the environment, perform proof of concept tests, and to demonstrate ISRU hardware all the way up to a pilot plant. At that said, again, demonstrating end-to-end capabilities at a sufficient scale that eliminates the risk of full-scale production. We're not saying that we're going to build a full-scale plant. We're not saying that no more engineering development will be needed to get to full scale, but that by performing these pilot plants at a sufficient scale, the next generation customer or the developer can take those technologies, whoever they may be, and advance them. And then eventually use these ISRU-derived products in mission-critical roles. So we're trying to break the chicken and the egg cycle of who develops the systems first, the users or the suppliers. And so we're working on that supply chain, making sure that the users eventually know that it's there. These charts, again, will be sent out so that you can look at them more in detail, but again, you have to understand the whole chain of events that need to occur, from understanding the resources to processing them, to delivering them and storing them and feeding them onto manufacturing and construction or life support. And so we need to make sure that in each one of these functional boxes, we are hitting the critical technologies where they need to be. And as you can see, I've kind of highlighted a number of the boxes that we're currently funding technologies on. and this allows us to basically understand that flow, the requirements in the interfaces that will need to occur when we transfer, whether it's the regolith or some intermediate process product downstream. Just to give you an idea, we have worked on oxygen extraction from regolith in the past. We performed several field tests where we demonstrated the technologies for a week or two, primarily hydrogen reduction and carbothermal reduction. But we have a significant amount of ongoing activities right now. We're funding 6 different oxygen extraction techniques through different programs, as I mentioned, depending on the technology readiness level, whether it's an SBIR or tipping point or internal. With respect to mining water, we don't know the form and the distribution of the water, how hard it is. So we're kind of covering our bets. We're looking at a number of different technologies, a number of different architectures that could occur. We're looking at a number of different mining sites locations and trying to understand the implications of how you would mine the water and convert it and deliver it to customers. And once again, based on the different types of concepts, whether you're excavating it and delivering it to a centralized reactor, whether you're heating the subsurface in a contained reactor like PVEX, or you're heating the subsurface and having the volatiles come up into some kind of a capture tent, we're trying to fund different efforts, again, until we learn more. We're working on water processing and water cleanup, which are incredibly important. Here again, looking at 3 different types of water processing technologies. The LSII has, besides the ground development, has picked these swim lanes, these 6 different areas, and has decided to perform several different missions along the way to advance the technologies, and the top one being ISRU. And I'll focus in a little bit more on the ISRU and the surface construction to give you an idea that we've already started. We have orbital missions providing data. We have 2 CLIPS missions that are planned in 2022 and 2023. Prime 1 is a stationary lander, and Viper is a rover excavator that Tony Colaprit talked about, I think, yesterday in a different conference. We're looking at pilot excavators and ice demos and O2 demos, and by the end of the decade, we want to do a significant pilot plant and a lunar construction demo. And with that, I'll bring my presentation to a close.
Thank you so much indeed, Jerry. Can you hear me here?
Oh, yes.
I'm going to throw you to Mel. Both of us have been watching the chat as you've been speaking. Lots of questions coming in, but due to running over time, I'm going to throw to Mel as the chair for this session to ask you at least one question. Mel, over to you.
Hi, Jerry. Thank you for the presentation. In the chat, there was quite some comment about SpaceX has been announced as the lunar surface vector. So how does that change your perspective on what comes first in terms of water, regolith, and so on and so forth? Thank you.
Not really. Again, we're not focusing just on one potential transportation system. We're trying to understand all potential transportation systems, whether they're the small robotic landers or the huge human landers. So I think with respect to the moon, we're going to continue on both paths and basically try to understand what the customers want. At the moment, we're focused at the South Pole, but if people want to mine, say, creep or rare earth elements at the equator, then we might focus on a different technology with partnerships. So it is important to understand all the customer needs, not just one, and to understand all the resources and what products may come out of it. And as I mentioned, in the end, really we're trying to enable commercial industry. So to some extent, we have this ongoing dialogue that Ben will talk about next, to help us focus on really what's wanted outside versus just NASA saying, hey, this is the way we want to go.
That's great. Thank you so much, Jerry.